Ahoy and welcome. So I'm still waiting for my 5/8 precision ground steel round bar to come. So the crankshaft has been put aside for the time being, and while I wait for that I'm going to move on to these two parts. Now here we are. There's the piece of 3/8 square bar that they supply, and simple enough parts. And what I would like to do is make use of my rotary table for these. So these two parts play together, so you can see this part has a tongue that will fit into this groove, and this part has a machined radius feature on it and a radiused end, as does this, so that they can swivel within each other. So a number of ways of making that feature. Of course, you can use a corner rounding end mill, stand this part up and round the corners. You can use a filing button to accurately hand file that shape, or you can freehand it. Dave Ticehurst in Australia has some really excellent videos about some of those hand techniques, and I know he has one about filing buttons, so I might put a link to that. But I've decided that the way I want to do this is to use a rotary table, and I'm going to use a technique and a tool that I got from Joe Pye. Here's the tool. Now you can certainly make these. I chose to buy one directly from Joe Pyezinski's website, and I'll put a link to that. He does two sizes of these. So there's a smaller version for smaller mills, but this is a really useful setting up tool. It's a 3/4 inch diameter with an accurately machined rectangular boss on the end. This face is accurately on center, and then these two faces are each 500 away from center, and this face is 500 away from center. So this becomes a really excellent tool for setting up a vise on the mill, or indeed has a number of other uses. But with that in mind, here is the teeny tiny toolmakers vise that I just acquired, and this is what I'm going to use to hold this piece of stock, and probably another piece of stock as well, to do this. So I can easily clamp this, and I can position it and find center with the milling cutter, and then the idea is that I will find this fixed face, position it half the thickness of the material so that I establish the center line of the material, and then I can use the rotary table to move this and rotate it around under the cutter to form that radius. So as I set it up, we'll get more into that. I'm going to use this tool to accurately find the location of the fixed face and get the center position, and then I will start by cutting this part, and we'll see how we get on. Alright, off to the mill. So this is my rotary table. It's a 6-inch rotary table. It's an import, but so it's a very reasonable price, and honestly the quality is actually very, very good for what I paid for it. So, and this is actually the first time I've used it, so which is one reason why I'm so interested in using it to put a radius on the end of this square bar, is because I just want to try it. So I have a 1, 2, 3 block clamped in place. This is going to provide a straight edge, and then the next part of the approach will be to use the alignment tool to position this vise relative to the center of the table. Now I've already found the center of the table. I used my coaxial indicator to do that, so that is set to 0. So this surface is now trammed and is moving parallel to the y-axis in and out of the machine. So now I can continue with the setup. So the basic idea here is to, let's see, set the vise up like this. And what I'll use is an adjustable parallel here to keep this vise parallel to this surface once I've established location of this surface. So right now we know that this surface is right on center line of the spindle. I found the center of this earlier on, so I can position the rotary table on the center of the spindle as well. So now what I'll do is return the spindle to 0. There we are. The table here is locked, by the way, so that I can't lose this position. Now we'll bring the alignment tool in. And we want to know where the fixed jaw is. Now I know that the fixed jaw is on the center line, but of course I have to position it this way. And I also need to move the fixed jaw of the vise half the thickness of the material I'm going to cut that way. So let's do that first. The square bar, which is allegedly 3/8, measures out at 0.375 and 0.375. How about that piece of stock that's dead on? So I need to offset the Y 0.1875. There we are. The resolution only allows me to go between 4 and 6, so we'll call that good. So we now have the vise positioned in the Y direction such that when the piece of material is clamped in, the material's center will be on center line. Now what I need to do is move the table over so that I can get a sliding parallel in there and allow the material to overhang the center of the table so that I can rotate the end of the material around center. So that should do it. Now, as you can see, we can put the sliding parallel in there, and we can make sure that there's no play in this vise. There we are, that's absolutely tight in there. Okay, so with that position, now I can clamp this in place, and what I'll do is I'll go off camera for a moment while I get some clamps and get that set up. Okay, so I've got the little vise clamped to the rotary table. Currently the center of the rotary table is 1876 inches away from the center of the spindle. So that sets the relative position of the back jaw relative to the center of the spindle. Now when I return the table to the 0 position, that will basically put the center line of the material on center with the table. So that's next, and then this vise is positioned to allow the material to hang over the edge so that when the table rotates, the end of the material can be cut. So let's get to that. I've repositioned this a bit and made sure that I've got enough material in front of the cutter so that I can get a full radius. The XY table is locked. I'm now going to unlock the rotary table. I've made a note of the position of the table so that I can return that to this position for drilling the center hole and for milling the top face. I've moved the table off 375, the diameter of the cutter, so that I'm sweeping the edge here, and now nothing remains but to try it. So let's see. Looks like I've got a full radius on there, so yeah, pleased about that. Okay, next step is to bring the part back, and I'm going to drill the through hole and machine the top tab. Now the drawing calls out a radius of the pocket in here of 0.19, and what they're really saying is just, 3/8. Which is the same dimension as they've called out for the radius of the pocket or the slot, well, the tangs on the mating parts. And if I make them both the same dimension, then they'll interfere. Since the stock is actually 3/8, 0.375, then if I actually make the radius of this pocket 190, that's a sensible thing to do. So 190 versus 1875 to give just that little piece of clearance. 1875 being the half of 3/8, i.e. the radius. So so I'm going to index over 2.5 thou. And then touch off on the top, and I will drive down the 120 that's referenced on the print, and then sweep to make that very slightly larger radius here, which seems like gilding the lily in a way, 2.5 thou, but whatever. It's all part of the fun. So first off, just lightly touch on the top, 0 to Z. Now I'll plunge 120. Next thing I'm going to do is drill the through hole, which I can then use to center this part again when I flip it over. I have to turn it over and make this same feature the other side. So while I've got the setup in place, I'm going to do the other part of the linkage, at least the radius part. So I'm currently at center. So again, move the table across, and it's half the thickness of this part plus half the radius of the cutter. It just so happens that this and this are 3/8. Alright, so I've got the part set up in the vise, just squared it up on a pair of parallels using a machinist square, and I'm going to establish height by touching off on the top of the parallels with a 5 thou feeler gauge. And then I'll be able to set that up on the DRO, and I will know where the position is for the height of the part. So just to demonstrate that, this is a little easier way of protecting the tips of an expensive carbide cutter. Just move the feeler gauge in and out. And now I feel a light drag there. So I know that the cutter is 5 thou away from the end of the part. So I can now program the DRO, and that's 0.745 minus, because the final length is going to be 3/4 of an inch. Now, when I come up and I reach 0, right around there, I know that the part, once it's machined, will be at the finished length. So I'm going to reposition the camera and begin cutting. And there we are, so that's the part finished to length. All that remains now is to put a hole in here, which according to the drawing is 3/16, 1/4 inch deep. So I will get set up for that. Okay, so put an edge finder in here, and I've also set up a handy dandy stop on the vise because I have to do some similar work on the other part of the linkage. This stop is by Edge Technologies, and they make some very nice tools actually. So maybe I'll put a link in the description below to that. So all that remains now is to find center of this part and drill that hole. So I'm going to make use of the half function on the DRO just because I've never used it before. I usually find the end points and then do the calculation and program it myself, but there's a half button here that's specifically for that. So let's see how that works. One side, 0 the X, up, point. I'm right over the centre of the part. So that's very handy. I'll do the same for the other direction. Saves me the extremely hard work of dividing numbers by 2. Alright, I'm going to swap over to the drill chuck now and finish this off. Okay, so I was about to change this all out, and then I thought, oh, I could chamfer those edges using a chamfer end mill. So I've put one in, and basically this part is 3/8 wide. There goes the compressor. So since I already know the 0, if I come out 0.1875, then I put the tip of the chamfer mill right over the edge of the part. So I've come out to 1/4 inch. And what I'll do is start this up, bring the chamfer mill down until I get the size chamfer I want, and that's just a visual thing, and then I'll lock that and I'll just walk around the perimeter of the part, put a chamfer all around it, and hope to God that that works out. Don't see why it wouldn't. So I took the part out, and then of course it became glaringly obvious to me that I hadn't yet milled the final slot. So I'm going to do that now. But of course this is all very simple because I've already established these zeros, and so I just put it back in the vise on a slightly taller parallel to give me the clearance. I'm actually going to mill it in the Y direction just because it's not supported very well in the X direction. And what I'm going to do is plunge cut the slot, take most of the material out, and then clean the slot up. This is a 1/8 cutter. The mating tang is exactly 125. I've just measured that. So what I will do is cut the slot, and then I'll move over 1 thou in each direction and do a cleanup. I've got some Sharpie on the top here to help establish the 0 point. So off we go. And done. Let's bring this out a little bit and see how this feels. Not bad. but still a little tight, so I'm going to take another thou off each side. That's as likely to have been the spring as anything that did that, but oh, that's much better. Oh, that's a perfect fit. Good. So now that part is done, aside from a little light deburr. Very good. Here are the finished parts, along with my teeny tiny vise. I really like this. That's going to be very useful for model engine parts. Anyway, have a look at these. Very pleased with how these turned out. I gave them a little bit of a polish with a wire wheel on a Dremel, just to shine them up, and not bad at all. The fit is absolutely perfect. There's no play in there at all, but nice free motion, and the pivot hole lines up nicely. I think the little chamfer on each end finishes it off. I wish I'd thought about that when I had these in the rotary table, because I could have chamfered all these edges, so next time I'll remember that. But there they are. Made a slight design change to that one. I made the part a bit longer than the drawing, put a thread in the end so that that can be an easily adjustable link, but there it is. And these are perfectly centered. There's no lip there at all, so I'm well happy with these. That's a successful first try of the rotary table, so thumbs up. Thumbs up. Hey. All the best, take care, and hope you get to make something fun soon, and hope you'll join me again. Really appreciate you following along. Bye bye for now.